Welcome back to the Tech Innovators Podcast. Today, we've got a topic that sits at the exciting intersection of machine learning and programming, the world of static embeddings with Model2Vec, specifically focused on its Rust implementation. So let's dive right in. Hey there, listeners. I hope you're all doing well. Today's topic is particularly thrilling if you're into natural language processing or programming in Rust. I've always found it fascinating how the language we choose can influence the performance of our applications, and that's precisely what we'll explore today with Model2Vec. So to kick things off, let's talk about what Model2Vec actually does. At its core, Model2Vec is designed for generating embeddings, which are numerical representations of text. Why does this matter? Well, embeddings enable machines to understand and process natural language more effectively. It's like giving them a secret decoder ring for human communication. Now, you might be wondering, how does Rust fit into this picture? The Rust implementation of Model2Vec, as we're discussing today, not only loads these embeddings, but does so at an impressive throughput. In fact, benchmarks show that the Rust version runs about 1.7 times faster than its Python counterpart. That's a pretty significant performance boost, right? Let's think about that for a moment. If you're working on a high-performance NLP application, that extra speed could mean the difference between a responsive service and a sluggish one. Now, imagining dealing with millions of text samples, that performance boost really starts to add up. So how do you get started with this Rust implementation? Well, it's designed to be quite user-friendly. You can load models either from the Hugging Face hub or even from a local path with just a few lines of code. Picture this. You've got sentences like, "Hello world," or "Rust is awesome." You run your command, and voila, your embeddings are created. It's almost like magic, but, it's really just great coding. And for those who might be a bit more advanced, there's even a way to customize your encoding, like tweaking the max length of input or adjusting the batch size. This flexibility ensures that developers can harness the power of embeddings to suit their specific needs. But let's not ignore the community aspect here. Model2Vec offers a variety of models that you can use right out of the box, and they're all available on the Hugging Face hub. Imagine the treasure trove of possibilities. Whether you're working on general tasks or retrieval tasks, they've got you covered. Now, you might be curious about the actual models available. There are models like the Potion-based 32M, which has over 32 million parameters. That's like having a small library of intelligent literature at your fingertips, ready to help machines understand language better. So, it's clear that the Rust implementation of Model2Vec embraces both performance and ease of use. But let's throw in a thought-provoking question. What are the potential applications of using such efficient embeddings in real-world scenarios? Well, you could envision advancements in chatbots, smarter search engines, or even improved accuracy in recommendation systems. The possibilities are virtually endless. Before we wrap things up, I'd like to leave you with one key takeaway. The choice of programming language can drastically impact the efficiency of machine learning models. Rust's performance with Model2Vec not only demonstrates this, but also highlights how critical speed and responsiveness are in today's tech landscape. Thanks for tuning in today. I hope you learned something new about how Model2Vec and Rust can contribute to the field of NLP. If you're curious about embedding models or have your own experiences to share, feel free to reach out. Until next time, keep innovating.